Hi, my name is Elise Stratil.
And I'm Tiffany Michalek.
Today we'll be talking about the effects acid mine drainage has on Sewickley Creek's water quality in macroinvertebrates.
Acid mine drainage occurs from metals and toxins in coal mines, which run off in the bodies of water, affecting the water and environment surrounding. Our hypothesis was that Sewickley Creek in time and space would recover from AMD due to passive treatment, which neutralizes acids and removes metals without pumping. We observed the Brinkerton site through sampling of benthic macroinvertebrates, chemistry analysis, and bioassay. This is a map showing our study area, including the total distance from Site 1 to Site 4 as 6.37 kilometers. The Brinkerton site is an 8-acre wet treatment system in Mount Pleasant Township in the southeastern part of Westmoreland County. The Sewickley Creek watershed, where the AMD site is found, is 50 square kilometers and is mostly agriculture with some residential forests. We took 3 macroinvertebrate samples from 4 different sites along Sewickley Creek. 3 different samples were collected in riffles for 1 minute, each by using a kicking net to catch the macroinvertebrates. The total area sampled per site was approximately 1 square meter. Water samples were taken at each site for chemistry analysis. Lamont colorimetry test kits observed the sulfate and iron concentrations along with turbidity. Alkalinity was measured using Lamont testers, while calibrated meters tested pH and conductivity. 10 live Daphnia were put in the water samples, including a spring water control site, upstream control, Site 2 10%, Site 2 50%, and Site 2 100%. We had 5 samples for each dilution, making that 25 samples total. Death rate was observed for 48 hours and analyzed during ANOVA.
These are a few important results that we found about each sampling method. Overall, we found that from 2016 to 2021, the number of macroinvertebrates increased going downstream. There is a decrease in macros in Site 1 compared from 2016 to 2021, which was the only site that decreased rather than increased. Our chemical analysis showed a decrease in iron for all sites except for Site 1. There was a major increase in sulfate from 2016 to 2021. The bioassay results show plus and minus 1 standard deviation of each dilution based on the ANOVA test. The controls showed an increase in mortality after 24 hours and a slight increase after 48 hours. This data is not statistically significant. Overall, we found that AMD has decreased. The increase in macroinvertebrate sampling and the decrease in iron are evidence that the stream is recovering. The Brinkerton site is one of many treatment sites that needs more funding. Though it's improving, it's not making the progress that it should be. The recent passing of the infrastructure bill is a positive step towards getting Brinkerton to where it needs to be, since it includes federal money to be spent on AMD cleanup efforts. Future research should include continuing the study because there is a lack of long-term AMD studies. Here's a picture of the Brinkerton site. On the left, you can see there are aerators put in place to oxidize iron. These aerators have been left unusable because there aren't enough funds, but if they become operational, this can be used to further research and to progress our current study now. Any comments or questions?